Hi, this is Megan Poff, and I'm the Field Office Chief at the USGS in Las Vegas, Nevada. I'll be talking briefly about the high watermarks and data you'll need for a slope conveyance measurement. The information presented in this video can be found in various hydraulics textbooks, such as Open Channel Hydraulics by Chow. So, what is a slope conveyance? A slope conveyance is one of the simpler methods of computing open channel flow, and it involves applying Manning's equation to a single cross-section. The equation is defined as Q equals 1.486 over N AR to the 2/3, S to the 1/2, where Q is discharge, N is a roughness coefficient, A is the area of the channel cross-section, R is the hydraulic radius, and S is the slope or energy gradient. Hydraulic radius R is just the area of the channel cross-section divided by the wetted perimeter. Wetted perimeter is simply the perimeter of the cross-section that is, well, wet. I know you're thinking, okay, Megan, how do these equations actually translate into me computing a discharge after a flood? Well, let's think about it. Based on the equations I just gave you, we need an area, a hydraulic radius, a slope, and a roughness coefficient. We can do a field survey of a cross-section and high watermarks to determine an area. Then we can determine a hydraulic radius based on the area and the wetted perimeter, which can easily be done with a spreadsheet. With that same spreadsheet, we'll plot our high watermarks and determine a water surface slope. And finally, we'll estimate the roughness coefficient using pictures and tables. See? It's really quite simple. What I'm getting at here is that the slope conveyance method needs a lot less data than the other indirect measurement methods that are described in this video series. Why wouldn't we do these for every indirect and save ourselves the trouble? Danger, hydrographer! Because a slope conveyance relies on a single cross-section, the flow estimates you compute can be 100% off of the actual flow. Let me give you an example from one of our gauges on the Virgin River for the flood of December 22, 2010. The channel was a non-uniform channel, and we computed a different type of indirect measurement first. However, this was an unusually large peak, and we wanted to check the original computation, so we ran several slope conveyances. For the same peak, separate slope conveyances computed anything from 21,700 CFS to 41,400 CFS. That's a huge difference for the same flood on the same river. Let's move on to finding a good location for a slope conveyance measurement. Slope conveyances, like any of the other indirect measurement methods outlined in this video series, assume that you have steady uniform flow. Steady flow means that your flow isn't varying by time, and uniform flow means that your flow isn't varying spatially, so the area and velocity should be the same. Generally, that's a safe assumption at the peak because we will have something that looks like steady and uniform flow after the rise and before the recession. We can take this concept and apply it to our slope conveyance indirect measurement. All we need is a single cross-section that is representative of the entire reach and will adequately represent the flow we are gauging along with high watermarks. Let me give you an example. Let's say we have a flow in a uniform concrete channel. This kind of situation is perfect for a slope conveyance computation because the area and velocities aren't changing. You will want to flag high watermarks on both sides of the channel. For more information on flagging high watermarks, please see the high watermarks video. The length of high watermarks can be nearly anything, but to be safe, try to get a flood channel width of high watermarks on each bank. For example, if your flood channel was 40 feet wide, try to get 40 feet of high watermarks on the banks. Your cross-section should be located approximately in the middle of your 40 feet of high watermarks. If you can only find high watermarks on one bank, it isn't a deal breaker. Go ahead and flag what you find. What if you are facing a situation where you have a channel that is only uniform for a very short distance and you need to determine a peak discharge? This kind of channel might be a good place for a slope conveyance as well, because the slope conveyance method doesn't require a long reach length. Pick a cross-section location and then flag high watermarks about a flood channel width upstream and downstream from your cross-section. Here is one last example for when you might choose a slope conveyance computation. Let's say you have a crest stage gauge only site, and you don't have a stage discharge rating defined for it yet. The purpose of the crest stage gauge is to measure the peak of the year, and your peak of this particular year was just over the pin elevation. That's a pretty minor flow, but we don't have a rating and we need a discharge. Doing a slope conveyance will be better than nothing and will be more defensible than some sort of visual estimate of flow. Plus, you'll have a point to start defining your rating. The slope conveyance method can also be used for rating extension. See Water Supply Paper 2175 for more information. Let me stress that for the most part, you will want to use a more robust indirect measurement method like a slope area computation or even any of the computations that involve a structure like a culvert or weir. Slope conveyances can be quicker than other indirect measurement methods, but they are less accurate and therefore should be used with caution. For information on surveying a slope conveyance in direct measurement, refer to the next slope conveyance video in this series. If you need help in the field, call your supervisor, surface water specialist, or indirect measurement specialist.